For centuries, space was just this realm of pure wonder. We'd look up at the stars and dream. But today, right above our heads, a massive and almost completely invisible transformation is taking place. Welcome to The Explainer. The final frontier has secretly evolved into a highly active, incredibly competitive economic and military theater. Behind all the flashy headlines of new scientific discoveries lies a fierce, covert global competition for technological leadership, economic opportunity, and, of course, geopolitical influence. Okay, here is our flight path for today's Explainer. We're going to start with 1, the new space race, then move into 2, satellites and global security, zoom out to 3, the corporate space boom, explore 4, the moon and Mars, and finally tackle 5, challenges of the final frontier. All right, let's dive right into this with Section 1, the new space race, from prestige to presence. Because to understand where we're going, we really have to understand where we started. The original space race was born directly out of the Cold War. Think back to 1957 when the Soviet Union launched Sputnik 1. This was a satellite literally no bigger than a beach ball, but it sent absolute shockwaves around the globe. It was a massive wake-up call that immediately turned space into the ultimate symbol of national capability. The Soviets followed up with another monumental milestone in 1961, sending Yuri Gagarin into space as the first human. And naturally, the United States responded with an absolute explosion of investment in aerospace, culminating in the historic Apollo 11 moon landing in 1969. But here's the thing. While these were incredible, inspiring scientific milestones, they were fundamentally driven by concerns over military technology, missile development, and sheer geopolitical influence. But today, the modern space race is a completely different beast. The original race was the strictly bipolar, government-funded clash of prestige between the US and the USSR. Now, it's a multinational, heavily corporate-driven scramble fueled by a really complex mix of scientific discovery, huge commercial opportunities, and a deep desire for strategic influence. We aren't just trying to prove who has the better rockets anymore. Actually, scratch that. It's more like we're trying to build the entire economic infrastructure of the future. And it's definitely no longer a two-player game. Just look at the players making massive strides in orbit right now. China has successfully landed robotic spacecraft on the far side of the moon and is aggressively developing advanced launch systems and their own space station. India has achieved remarkable success with incredibly cost-effective planetary missions. In fact, their Mars orbiter famously cost less to build than the Hollywood movie Gravity. And we absolutely can't forget Europe and Japan, who are contributing cutting-edge scientific research, vital Earth observation, and really driving international partnerships forward. It is a crowded, highly active arena up there. Which brings us to Section 2, satellites and global security, the invisible economy in low Earth orbit. Let's look at the immediate stakes playing out right above our heads. I want you to think about this question for a second. Seriously, what happens if we lose our satellites? Think about your morning routine today. Think about how you navigate your commute, how you tap your phone to buy coffee, or how you'd coordinate with your family in a crisis. What's really interesting about all this is just how deeply vulnerable our modern way of life actually is. Thousands of satellites are currently orbiting Earth, and they act as this invisible backbone for our entire society. We rely on them for GPS navigation, mobile communications, and TV, sure, but it goes way deeper than that. Global financial transactions, aviation and shipping networks, weather forecasting, disaster monitoring, they all depend heavily on this space infrastructure. A failure up there, it would immediately trigger a catastrophic collapse of our modern economy down here. Because our modern economies rely so extensively on these systems, protecting them is now a massive, absolutely crucial national security priority. And this brings us to the darker, highly classified side of the new space race. Anti-satellite technologies. Nations aren't just exploring anymore. They're actively developing weapons capable of blinding or permanently destroying operational satellites in orbit. Policymakers are deeply concerned about the militarization of space. The focus right now isn't necessarily on, deploying conventional weapons, but rather on ensuring satellite resilience, upgrading cybersecurity, and building backup systems so our essential services can survive even during intense geopolitical conflict. Let's shift gears to Section 3. The corporate space boom, slashing the cost of orbit. Because private companies have completely rewritten the rules of how we get to space. For decades, going to space was so incredibly expensive that it was a strict monopoly held exclusively by national governments. But today, commercial aerospace companies are innovating at a truly unprecedented pace. The real game changer here is reusable rocket technology. By landing and reusing boosters, these companies have slashed the cost of sending payloads to orbit by an order of magnitude. sometimes by over 90%. They've effectively ended the government monopoly on space access. And this cheap access to orbit, it's unlocking entirely new, rapidly expanding commercial markets. We're talking about satellite internet finally connecting remote communities around the globe. We have precision agriculture dramatically improving food production from above, and vital environmental monitoring for tracking climate change. And if we look just over the horizon, things get wild. Space tourism, commercial lunar landers, and even the trillion-dollar potential of asteroid mining to access valuable metals. Public-private partnerships are proving that space industries are going to be a massive part of the global economy in the coming decades. Moving further out, we hit Section 4, the Moon and Mars, the strategic outposts. Because our goals out there have shifted dramatically since the Apollo era, the Moon has once again become the central focus of international exploration. But this time, it's not just about planting flags. It's about establishing a sustainable, long-term human presence. Think of it as the lunar stepping stone. Scientists have found highly valuable resources there, specifically water ice trapped in permanently shadowed craters near the poles. So the plan is pretty incredible. Step 1, extract that water ice. Step 2, convert it. That ice can provide drinking water, breathable oxygen, and crucially, hydrogen for rocket fuel. Which leads to Step 3, use this sustainable lunar base as a launch pad for long-duration human missions deeper into space. It's basically an off-world gas station. And those deeper space missions lead us directly to Mars. The red planet is humanity's next great frontier. Robotic missions have already sent back incredible data, showing us evidence of ancient rivers, lakes, and conditions that might have once supported microbial life. Finding clues about past life is mind-blowing for sure, but actually getting humans to Mars and keeping them alive there, that's humanity's next massive engineering hurdle. So the crucial point is that surviving on Mars will require entirely new approaches to long-duration space travel. We can't just slap new paint on Apollo tech. A successful mission demands entirely new, advanced spacecraft. We're going to need highly reliable life support systems that can run for years without a single resupply from Earth. We have to solve the incredibly dangerous problem of deep space radiation, and we literally have to invent extraterrestrial agriculture to keep crews fed. Pulling this off would be one of the greatest scientific achievements in human history. Which brings us to our final stop today, Section 5, Challenges of the Final Frontier, Debris and Diplomacy. Because all these ambitions face some massive physical and political roadblocks. Despite all our remarkable progress, we've created a very serious, very physical problem just outside our atmosphere: space debris. Right now, there are thousands of inactive satellites, discarded rocket components, and tiny fragments just whipping around the Earth at extremely high speeds. Up in orbit, a tiny piece of debris the size of a paint chip is traveling at roughly 17,000 miles per hour. That is fast enough to completely obliterate a multi-million-dollar spacecraft. And as we launch more and more into orbit, this lethal threat just multiplies exponentially. So how do we fix it? Well, even as nations secretly compete for dominance, solving the debris problem and surviving deep space requires one thing above all else. As our source material wisely notes, humanity's greatest achievements often result from cooperation rather than competition alone. International partnerships are absolutely vital here. We need collaborative missions to share the expertise, reduce those massive costs, improve our debris tracking, and ensure sustainable operations. Even amid fierce competition, nations have to find ways to work together on scientific research, satellite monitoring, and astronaut training. Which leaves us with this ultimate, provocative question to ponder. Who will light the rules for humanity's final frontier? The secret race for space domination isn't just about reaching distant planets anymore. It's about determining exactly how peacefully, sustainably, and collaboratively our civilization moves forward. The decisions we're making in orbit today, they're going to shape humanity for generations to come. Thanks for joining me for this explainer, and hey, keep your eyes on the skies.